This is Shelby with the Rogers Public Library. So this week for Full Steam Ahead, we're talking about simple machines again, specifically inclined planes, and two others that are related to them. Those are the wedge and the screw. But first, let's just focus on this, right? So an inclined plane, it's basically, another name for it is a ramp. It's basically a triangle, or a right triangle, and it makes it easier to move things up, right? Because you're moving it along a slope instead of just going straight up like that, right? And so we know from the other simple machines that we looked at that the way that they provide mechanical advantage, that they make work easier, it has to do with the length, right? So we have a side here that's labeled as length, and we have two others. This is a run, that's the horizontal distance between the 2 points here, and then the rise is the vertical distance. And the length does matter when we're talking about the mechanical advantage of an inclined plane, but there's some other stuff to consider as well. So like for instance, if we have these two inclined planes, right, it's the same length, these identical triangles, the same length, but if you look at these, you probably think to yourself that, well, if I was trying to move something from the bottom of this ramp to the top of this ramp, it'd probably be easier to use this one than this one. And you don't have to take my word for it. We can actually do an experiment here that kind of demonstrates this in action, right? So I have some pieces of cardboard. I wetted the end of this and then I folded it at a 90-degree angle, right? So that way it just hooks on here, and it'll be stable. This is like a rack that we have to hold die cuts, but it's about the right size for this, so we're using it as a ladder, I guess. This is another ramp that I made. I ended up actually making this one first. I glued pieces together, but this was easier in the long run. But I'm going to show it to you guys because it has an equation on it, right? It's F equals ma, and this is the definition of force, right? I think I mentioned this before, but force is mass times acceleration, but it bears elaborating on for this, right? Because if we're trying to measure the mechanical advantage of an inclined plane, one way we can do that is by saying how much force it takes to, or how much force a thing rolling down the plane has. And we can measure that indirectly by acceleration, right? So if we know the acceleration of an object, we know its mass in grams or kilograms or whatever, we know the force that it has. And we also know that motion happens when there's an imbalance of forces, right? So if we're holding this still on the inclined plane, we're using a force on it that's equal to the force that's going this way down the ramp. And if we want to move it up the plane, we have to use a greater force than that, right? So the faster it accelerates down the ramp, the more force it takes to move it up the ramp, right? And this is a cool setup because the length never changes, right? It's just the height and the acceleration. So we have a controlled factor. We can see when it's very low, it moves very slowly. Move it up 2 rungs. It's faster now. Move it up another 3, I think. Now it's really fast, right? So there's the force that it takes to move up an inclined plane isn't just about its length, right? The height matters too. But if we think about it a little bit more, we can see that the length is important as well, right? So say we put it on this run. Let me see how fast it goes down. Okay. What about if we use a smaller piece of cardboard? It's kind of hard to tell because this one is so small, but at least for my money, it seems like this is accelerating faster, right? So, and the reason for that is because of not just the length, not just the height, but the relationship between the two, right? And so the degree between the length of the inclined plane and the ground, right? So we can talk about that in terms of like angles and degrees, but we can also talk about that as a ratio, right? So we could say specifically this is called a cosecant, right? So cosecant is It's a trigonometric function, but you don't need to know that. You just need to know that it is the length divided by the height, or the distance that it rises, right? And so we can do a little bit of math and a little bit of trigonometry, and we can find out that if we had an inclined plane like this, then the mechanical advantage that it gives us is this number right here, 1.588, and multiplies the force that we have going up the ramp, right? So, that math is just a fancy way of telling us what we already know, which is that it's easier to move things up very gradual slopes than it is to move things up a very steep slopes, right? So what about wedges and screws, right? So these are just variations on the inclined plane. So the first one, the resemblance is pretty obvious. So this is a wooden knife. It's nice to use because we can't actually hurt ourselves with this. I really want to emphasize that you shouldn't be playing with knives at all. But wooden knives are okay. So, but it has this kind of an edge that kind of tapers off into a point, and because of that, it concentrates force onto a very small area, and that lets it chop things like that. And that's why you use knives to cut up food, or people will use similar tools to chop up wood, like axes. There's another type of wedge too, and that's one that holds things together. So you guys probably know about these. You have a bunch of them in your houses. This is a screw. So the end tapers off into a point, right? So it's a triangle, just like the other ones that we had earlier. And that the fact that it tapers off to a point makes it so that we can drive it into pieces of wood. And then what actually holds them together is the friction between the sides of the nail and the grain of wood. And then then we're going to talk about screws. So I have a couple different ones here. And the resemblance isn't exactly as obvious. But let's say, so if we have a triangle like this and we wrap it up on itself, well, it looks like a lot like a screw now, right? It's a cylinder, and it has this kind of swirly helix going around it, like the screw. So these aren't the only types of screws, right? These are specifically fasteners. So they do the same thing that nails do. They hold pieces of wood together. And there's another type as well called a bolt. It was technically a nut and bolt. This little part at the end is called a nut, right? And you use these to hold pieces of metal or plastic together, or sometimes wood, in terms of like furniture and stuff that you want to be able to take apart, whatever. But like I said, there's other ways that you can use screws too. There's something called an Archimedes screw, which is actually a type of water pump, right? So you can use screws to move things. You can also use screws in tools. So this is a pipe wrench, and it's got a screw on the side, and it lets you tighten and loosen it so that you can grab onto pipes. And again, as a disclaimer, these aren't toys; these are tools. Your parents might have some of these at home, and they might let you look at them under their supervision, but you shouldn't play with them on your own, right? So we have this, and this also illustrates some other cool things about screws. The first is that they turn rotational motion into linear motion. So if I spin this around in a circle, it makes the teeth move up and move down, right? So that's one way that screws are useful. The other way is that they're self-locking. And what that means is that I can pull on this all day long. I can push on it all day long, and it's not going to move. The only way to make it move is to spin it, right? It doesn't turn linear motion into rotational motion. It just turns rotational motion into linear motion. And that's really useful when you need to hold things together, right? So like screws, they're really good at holding things. They don't come undone very easily. And that's also why you have a lot of bolts and stuff on machinery and cars and things like that. This is another tool that uses a screw mechanism to adjust its teeth, called a vice grip. So it's a type of vice, which is just something that you use to hold things together that you want to work on. You can set it to about the right size, and now I can hold this together and just mess with it. So those are pretty cool as well. But so yeah, that is inclined planes and screws and wedges, and now we're gonna get on to the craft. For this craft, we're gonna be using a slinky as kind of like a painting brush, right? So if you look at a slinky, you can tell it kind of right away that it's a cylinder, right? And if you pull it apart, these are stuck together, you can see it's a spiral or a helix, just like the screws that we looked at earlier. But is it a type of screw? I actually tried to hold two pieces of cardboard together with one, and it kind of works. And I think if I had tried a little bit harder and had something to cut holes that were the right size, I could have made it work better. But they're really not meant to be fasteners or simple machines. What they are springs, right? So they bounce and they store energy. So this is actually a type of extension spring, which means that it stretches out instead of squishing together. But so for what we need for this, we need a slinky. We need a box to keep our paint in place, and then we just need a couple different colors of paper. So there's a couple different ways that you can use this kind of as a brush. There's the obvious way, which is just bringing it down like that and making nice circles or something like circles. It's easier when there's more paint on it because the weight makes it easier for it to stretch out. You can do some other stuff too, though. You can, for instance, do this, put it in the side and roll it. Make some nice kind of like comey patterns. This is very messy, as you can see from my hands already. You can also go like this and make it's almost like stippling when you just dot things with your brush. And you can, of course, use both ends to bounce at once. It's a little bit harder, right? And of course, you can try to keep the colors separate if you want and use different slinkies, but it's going to be messy no matter what. So I don't think this is really one where you want to worry about mixing colors. Now, you do this as well, like kind of wavy patterns. Right, and then as for what the finished artwork looks like, or what it looks like when it dries, we have this guy here using purple and red and blue. And we have this one as well. Yeah. So yeah, it's a pretty easy and it's pretty fun. And you get nice and messy. But that's our craft for this week. I hope you guys liked it. So just as a quick note, this is the last full steam ahead for the year. But we're going to be back in January with some more videos for you guys. I'll see you then.